Hello everybody, welcome back to my channel. My name is Dave. Today is the 6th of September 2020, and this will be a quick review about absolute value. For those of you who are in Algebra 1, this is coming from the textbook Holt-McDougall, Explorations in Core Math 1.7. As a quick overview, in today's lesson we'll be talking about the definition of absolute value. Then we'll look at evaluating some absolute value expressions with numbers. And next we will go on to solve some absolute value equations. So absolute value, what is it? The first definition is that it is the distance that a number is from 0 on the number line. For example, if I wish to find the absolute value of positive 7, that would be equal to 7. 7 steps for me to get back to 0 on the absolute value number line. Similarly, if I want to find the absolute value of negative 5, the absolute value of negative 5 would be simply equal to 5 because it has a distance of 5 from 0 on the number line. In other words, I must take 5 steps to get back to 0. A different way to think about it is that the absolute value is always positive. If a number is positive, it stays positive. If a number is negative, you simply remove the negative sign and make it positive. What does this mean? Well, if I want to find the absolute value of 12, the absolute value of positive 12 is 12. Nothing will happen to it. However, if I want to find the absolute value of negative 12, I simply remove the negative sign and make it positive. So the absolute value of negative 12 is positive 12. Similarly, to find the absolute value of negative 4, I remove the negative sign and make it positive 4. However, the absolute value of 4 is 4 because 4 is positive and it stays the same. Lastly, if I have negative 1/2 and I want to find the absolute value, I simply remove the negative sign and get positive 1/2. And to find the absolute value of positive 1/2, it stays the same, and again, the absolute value of 1/2 is positive 1/2. One important thing to remember is that absolute values work similarly to parentheses. Recall that when I'm following my order of operations, parentheses take precedence over all other operations. So therefore, if I see absolute values, I have to evaluate what is within the absolute value sign first. Let's take a look at this example. The absolute value of the quantity 4 minus 10. If I simplify what's inside the absolute value sign, I will get the absolute value of negative 6. And because negative 6 is negative, to find the absolute value, I must remove the negative sign and get positive 6. For this one, the absolute value of the quantity 10 minus 4, again, I simplify what's inside the absolute value sign first, and I get the absolute value of positive 6. This gives me 6. Remember that if a number is positive, the value does not change when you take the absolute value. Let's take a look at this example, the absolute value of negative 4 plus the absolute value of negative 5. Because both of these numbers are negative, I remove the negative signs and I get 4 plus 5, which is equal to 9. If I have the absolute value of negative 4 minus the absolute value of negative 5, once again, I will remove the negative signs and get 4 minus 5. Of course, 4 minus 5 is equal to negative 1. Here is a slightly more difficult example. Here we have 2 times the absolute value of the quantity 3 minus 2 times 5. Recall that absolute values work similarly to parentheses. This means that I must evaluate what is inside the parentheses first. So, if I look at what's inside the parentheses, I see that I have 2 times 5. And since multiplication takes precedence over subtraction, I now have 2 times the quantity 3 minus 10. This gives me 2 times the absolute value of negative 7. Again, because negative 7 is negative, I will remove the negative sign and I'll simply have 2 times 7, or 14. Let's take a look at a different example. And I want you to try this one by yourself. So pause the video for as much as you need and try and evaluate this. All right, so as we said before, we must take care of what is inside the absolute value first, and because what's inside the absolute value contains a multiplication, we do 8 times 7, which is 56, and 56 minus 100 is equal to negative 44. However, since negative 44 is less than 0, we will remove the negative sign and get 44 over 4, or 11, as our final answer. Now let's move on to solving absolute value equations. The key to solving these kinds of equations is to isolate whatever is inside the absolute value marks, no matter how complicated, then write two equations. Our very first example will be something that's relatively simple. The absolute value of x is equal to 7. Now, we have to think which values can give an absolute value of 7. In this case, it's fairly obvious. X can be positive 7, or x can be negative 7. At this point, the equation doesn't need to be solved any further. So the solutions are simply x equals negative 7 or 7. Let's take a look at another example. So we want to solve the equation 3 times the absolute value of x is equal to 15. We should notice here that since the 3 is outside the absolute value brackets, we must first divide both sides by 3. That is, we have 3 times the absolute value of x divided by 3 is equal to 15 divided by 3. Now this will give us the absolute value of x is equal to 5. And now we think to ourselves, what values of x give a value of 5? And again, it's pretty obvious here that x is equal to negative 5 or 5. Moving on, let's look at another example. In this one, we want to solve the equation the absolute value of x plus 7 is equal to 11. Since 7 is outside the absolute value brackets, we will subtract 7 from both sides. And we will get the absolute value of x is equal to 4. And again, we will think about what values of x can give a value of 4. And the values of x that give an absolute value of 4 are negative 4 and positive 4. This equation is slightly different. Notice that the absolute value contains the expression x plus 3.2 is equal to 1.8. That is, 3.2 is inside the absolute value brackets. This means that the entire quantity x plus 3.2 has an absolute value of 1.8. In other words, we're going to have to write two equations, two one-step equations. The first is x plus 3.2 is equal to 1.8, or x plus 3.2 can also equal negative 1.8. We can solve these two equations separately. So if we subtract 3.2 from both sides in the first equation, we have x is equal to 1.8 minus 3.2, or x is equal to negative 1.4. In the second equation, we subtract 3.2 from both sides, except in this case we have negative 1.8 on the right-hand side. So Negative 1.8 minus 3.2 is equal to negative 5. The solution for x is x could be negative 1.4 or negative 5. Of course, we can always check our solutions, and we will do so on the next slide. So remember we had the equation, the absolute value of the quantity x plus 3.2 is equal to 1.8. And we obtained for x the solutions negative 1.4 and negative 5. We can simply put these into the equations. So if we insert negative 1.4 plus 3.2, we do indeed get 1.8. And similarly, if we put negative 5 plus 3.2, we get the absolute value of negative 1.8. But remember that anytime a number is negative, we remove the negative sign and get the positive number without the negative sign. So again, the final answer is 1.8. These answers check out. Let's move on to a slightly more complex example. In this example, we wish to solve the equation, the absolute value of the quantity 3x minus 1 is equal to 20. You must realize that when we have the absolute value symbol, the entire quantity inside the absolute value could be equal to negative 20 or positive 20. In other words, the possible values for 3x minus 1 are either negative 20 or 20. Therefore, we will write two different two-step equations. The first equation will be 3x minus 1 is equal to positive 20. The second will be 3x minus 1 is equal to negative 20. We can solve both of these equations separately. And if we solve the first equation, we will add 1 to both sides, and we'll get 3x is equal to 21. And then we can divide both sides by 3 to get x is equal to 7. For the other equation, we will again add 1 to both sides, and we'll get 3x is equal to 19. When we divide both sides by 3, we will get negative 19 over 3. Remember that in Algebra 1 and in your subsequent math classes, it's perfectly fine to leave your answer as an improper fraction. Therefore, x equals negative 19 over 3 is your final answer and doesn't need to be modified further. So, as we said, our solutions are either x is equal to positive 7 or x is equal to 19 over 3. As a final example, let's take a look at this. Solve the equation 3 times the absolute value of 2x plus 4 minus 9 is equal to 51. As a reminder, the first step should be to isolate the entire expression within the absolute value, and then to write two separate two-step equations. Pause the video and try this by yourself. If you try to isolate this, the first thing to do is to add 9 to both sides. This will give us 3 times the absolute value of the quantity 2x plus 4 is equal to 60. Next, you will divide both sides by 3, and you'll get the absolute value of 2x plus 4 is equal to 20. At this point, we realize that the whole quantity 2x plus 4 can be either equal to 20 or negative 20. So here we will write two separate two-step equations. The first equation will be 2x plus 4 is equal to 20. And if you subtract 4 from both sides, you will get 2x is equal to 16, or x is equal to 8. For the second equation, we will have 2x plus 4 is equal to negative 20. And again, we will subtract 4 from both sides to get 2x is equal to negative 24. And we'll divide through by 2 and get x equals negative 12. Therefore, our solution is x is either equal to 8 or negative 12. This is the review for today. If you like this, please ask some questions or leave some comments down below. And if you like, please also subscribe or give me a thumbs up on this video. Thank you very much.